In this video, I am going to show you how to use ControlNet for Flux within ComfyUI to unlock the full potential of your image creations. We will cover how to install Flux ControlNet, build the workflow, and I will share some tips for getting the best results. Stick around until the end. You are going to learn a lot. Let us dive in. Before we begin, let me quickly explain what ControlNet actually is. ControlNet is a powerful tool that allows you to better control image generation using image inputs. It does not just rely on the prompt anymore, but also incorporates elements like depth maps or sketches. This gives you the ability to, for example, transfer body poses or features from one image to your generated image. ControlNet for Flux is not as refined and advanced as ControlNet for the stability models yet, but over the next few months, we can expect improvements and many more models will be added as well. If you want to learn more about ControlNet in ComfyUI, feel free to check out my other ControlNet video. Now let us move on to the installation. The very first thing you need to do is click on the download link for Flux ControlNet in the description. This will bring you to this document where you will find all the links you need and a few additional pieces of information as a reminder in case you forget anything. At the top, I have also linked my Patreon where you can support me. By becoming a supporter, you will get access to my workflows from my ComfyUI videos, which you can easily download. This will save you the setup process, making it easier for you to follow along with the installation, since you can also use the manager to download any missing nodes. Additionally, with the Flux ControlNet Workflow, you will get an upscaler, face fix, and many other cool workflows. But now, let us get back to the installation. The first thing we need to download is the XFlux nodes. To do this, click on this link here. First, download the zip file and place it in the custom nodes folder inside your ComfyUI directory. Note that my file path might differ from yours since I am using Pinocchio, but you should have a similar path. Once you have placed the file there, extract it. Ensure that only one folder is created. In my case, 2 folders were created, so I had to correct this by merging them into one. After everything is ready, run the setup file, which will download the necessary packages. Now, we need to quickly start ComfyUI so that the required folders are created. Once you have opened ComfyUI briefly, you can close it again and we will proceed to download something else. Next, we need to download the ControlNet models. For this, click on the link in this document. When you land on the website, go to the section where you can download the latest versions. In my case, version v3 of Canny, Head, and Depth. Navigate to your ComfyUI models folder, then into the newly created XLABS folder and place the ControlNet models inside the ControlNet folder. Once you have done that, we also need to download the ControlNet aux nodes. Click on the link in the document and download the zip file to the custom nodes folder in ComfyUI, then extract it there. I have already done this, so I do not need to do it again. Now that you have completed all these steps, we can start building our ControlNet workflow. For all the Patreon supporters, you can skip the setup and simply drag and drop the workflow. For everyone else, do not worry, I will show you how to set it up yourself. Even my supporters should watch, as you will likely learn something new. If you are a beginner, I recommend watching my ComfyUI tutorial series, which will make understanding the videos and workflows easier for you. First, we need the Load Diffusion Model node to load our Flux model. Then, we will add the Dual Clip Loader, which allows us to load our clips. Once that is done, we will add the Load VAE node to load the VAE model from Flux. I will now configure the clips for Flux and change the type to Flux. Simply copy these settings exactly. If you do not have the Flux models yet, check out my Flux tutorial video. Once that is done, we need the clip text encode nodes for Flux, one for positive and one for negative prompts. We will connect these to the clip loader. Next, we will add the XLABS sampler node and connect it to the nodes we have already set up. Make sure to follow along and do it exactly as I am doing here. Next, we add the latent image node, which allows us to set the image size and the number of images to be generated. After that, we need the Load Flux ControlNet node to load our ControlNet model. You will see here that the 3 downloaded models are displayed. Now, we need this node here, which lets us load the preprocessors for the respective model. We connect this to the Load Image node, which is our input image, from which ControlNet will take its features and apply them to the generated image. You will notice that there are many preprocessors available, but unfortunately, only 3 are available for Flux. For example, if you are using the Canny model, simply select the Canny preprocessor here. Now, we create the Apply Flux ControlNet node and connect it to the other nodes. You can adjust the strength of ControlNet here. The higher the value, the more influence it will have on the generated image. I personally like to set it to 0.7, so the model still has some room to generate its own elements. Now, connect everything to the XLABS sampler node. I will also create a preview image node so that you can see what ControlNet is generating. This is optional though, you do not have to do it. Now, we need to add a VAE decode node, connect it to the VAE and the sampler node, and create another preview image node where the final image will be displayed. And with that, our workflow is complete and we just need to adjust a few minor settings. If you are using the dev model, set 20 steps here. For CFG, you can choose when your prompts start affecting the image. I set it to 1 so that my inputs are applied to the generated image right right from the start. For true GS, keep it between 1 and 3. If it is set too high, it will degrade the image quality. Regarding CFG, these settings have minimal impact on the image, but you can experiment with them to see how they affect your image. First, I will show you the head ControlNet, and I will select the appropriate model and preprocessor for it. Now, I'm going to show you a few examples. I will input my prompt at the top and apply it twice in both windows. I will now combine the prompt with the features of the input image to generate our new image. The structure of the input image will be preserved, but instead of a European woman, an Asian woman will be created, as specified in the prompt. As you can see, ControlNet has captured the features of the input image and is applying them to our new image along with the new prompt. I will now skip the generation time, and here we have an Asian woman who closely resembles our input image, as most of the original features have been transferred. You can increase the strength of ControlNet to make the result even more similar, but be careful to find a balanced setting. If you set it too high, the influence of the prompt on the image will decrease. In my opinion, a value between 0.7 and 0.75 works best. If you have enjoyed the video so far, do not forget to leave a like and subscribe to the channel for more videos like this one. Now let me show you how this works with the depth model. As you can see, the results are really good here as well. However, I primarily use depth for objects. For people, it is also fine depending on the type of image you want to create and which features you want to copy. Just choose your ControlNet model accordingly. Experiment a lot here. The more you try, the better you will understand how the model affects your image. Now let me show you how it looks with Canny. With Canny, you can really see how well it captures the features of my input image. It even generated the earring. If the earring was missing with other models, you can incorporate features from the input image directly into the prompt to ensure they appear in the generated image. Now I will move on to my workflow and show you a few more examples. Here I have generated an image with mountains and sheep, and I want to use ControlNet to change the season. To do this, I will adjust the prompt to include snow, and we will start with the depth model. As you can see, some features were transferred, but not all of the mountains, as the depth model did not recognize everything. This would have been possible with the stability models and their ControlNet versions. Unfortunately, the current depth model from Flux does not seem to handle this perfectly yet. One of the sheep is also missing. I think if I generate a few more images and tweak the prompt and ControlNet strength, the third sheep should appear. As I mentioned earlier, play around with the values and the prompt until you get your desired result. Now, I will drastically increase the ControlNet strength and show you an example with head. Here, the features were almost perfectly transferred, but the image quality suffered a bit. The result would have been better if I had lowered the strength of the ControlNet model or added photorealistic to the prompt, for example. Now, let us look at how it would turn out with Canny. This model seems to be the least suitable for landscapes of this type. I will also show you an example with objects. For instance, here is a house where I wanted to change the color of the flowers. Of course, you could do this better with in-painting, but I wanted to show you how ControlNet transfers the image's features based on the model and input image. Here is another example using the head model, where the pose of a ballerina was added to our image. Due to the size difference between the input image and the generated image, the pose was stretched a bit horizontally. You can fix this easily by increasing the height of the image. I have included a size chart in the document in case you want to use different dimensions for your images. For my supporters, you can find the size values at the top of the workflow. Here is an example where I increased the image height. As you can see, it looks much better now, but do not forget to adjust the resolution for the ControlNet model as well. You can also resize the image using Photoshop or another editing tool if you do not want to change the size within the workflow. Lastly, here is another example with the head model, where I changed the woman's skin tone. You can see that the features were transferred very precisely. And with that, this video is coming to an end. If you have not seen my previous ComfyUI videos, feel free to check out my playlist or watch my latest video. Thank you for watching, and see you next time.